Section 8.3 is on factoring trinomials that have a coefficient in front of x squared. When there's a coefficient in front of x squared, my parentheses can't start simply with x and x because there needs to be a multiplicative value that isn't just 1 in front of the x squared. So I'm going to try to find two numbers that multiply to the coefficient of x squared and two numbers that multiply to the constant c, where their mixed sum adds to the term in the middle. If I can't find the combination, the polynomial is prime. Okay, so we're going to try factoring by trial and error in this first set of examples here. All right. Now, by trial and error, I know I'm going to have a number of x times another number of x, and the number that I have needs to multiply to 2. So the only way to multiply to 2 is with 2 and 1. Now the other numbers need to multiply to 15. There's a couple different ways to fill in the second half of the parenthesis here. Let's try 3 and 5. I know that since 15 is positive, and I'm adding to a positive 13, that it needs to be two positives. Let's do our trial and error check right here. I already know that 2x times 1x gives me 2x squared. What I need to check is the mixed terms, the terms that involve a constant and the x. So the outside 2 and the inside 2. The outside 2 are going to multiply to 10x, and the inside 2 are going to multiply to 3x. And so I have the total of 13x. We got it on the first try. So the answer here is 2x plus 3 times x plus 5. All right, don't expect to get it on the first try every time with trial and error. Let's try another one. 15q. So I know that the coefficient of q needs to multiply to 15. So there's a couple ways to do that. One of them would be with 3q and 5q. Let's start with this one. If 3 and 5 don't work, we'll try 15 and 1. So 3 and 5. Let's try to get to 6. Let's try 3 and 2 multiply to 6. Let's check to see if we managed to get the 23 from our mixed sum right here. 3q times 2q is 6q. And 3 times 5 is 15. Now these were both going to be additions again because we knew it was a positive product and a positive sum. 6q plus 15q is 21q. So this one does not work. Let's try again. Maybe the 3q and the 5q were correct, but we got the 3 and the 2 wrong. So let's try to change those up. We can change it to 2 and 3, or 6 and 1. If I change it to 2 and 3, I get 9q plus 10q is 19q. So again, this didn't work. Okay. Let's clear our space. So far we've tried 15 as 3 and 5 and 6 as 2 and 3. Let's continue trying the 3 and the 5, but we're going to try 6 and 1. 3 times 6 is 18. 1 times 5 is 5. And if you add these up, you get 23. So this one works. My final answer is 3q plus 1 times 5q plus 6. If trial and error isn't your thing, you can also try to factor by grouping. If you're going to factor by grouping, what you need to do first is multiply the coefficient of x squared, a, times the constant term, c, and then factor as if this were a trinomial with coefficient 1. So if I multiply 3 times negative 12, that's going to give us negative 36. Take your negative 36 and break it down until you get two numbers that add to 16. 36 is negative, so I know I have one positive and one negative. And the larger one needs to be positive to add to the positive 16. So what goes into 36? We could try 12 and 3. 12 minus 3 gives us 9, so that one doesn't work. 6 and 6 would have given us 0, so that doesn't work. Or 18 and 2. 18 and 2 give us 16, so that one is going to work. Now how do we take these two numbers and factor? These two numbers are the way that you need to break down the 16 to get this to factor. So we're going to rewrite our question as 3x squared plus 18x minus 2x minus 12. We removed the 16x and unsimplified it to 18x and 2x. Now we're going to factor by grouping in my two groups right here. The first group can both be divided by 3 and x. So it'll be 3x times x plus 6. And I divide them both by 3x. The second two terms can both be divided by negative 2. So if you divide out negative 2, you're going to get x plus 6. You can see that you have the same group right here, x plus 6. So we're going to factor into x plus 6 times 3x minus 2. This is an alternate to using the trial and error method. You can factor by finding the two terms that I can break down and group with. Let's try this method again. Start by multiplying the coefficient of a squared and the constant term. So 12 times negative 5 is negative 60. Now, since that's negative, I need one positive and one negative that are going to add to negative 4. Since the 4 is negative, the bigger one needs to be negative. Okay, it goes into 60. I know that 60 is 10 times 6, so if I try negative 10 plus 6, that's going to give me negative 4. So I found my pair. Now, the 10 and the 6 right here are what I need to break the negative 4a down into. So we're going to write this as 12a squared. In place of the negative 4a, we're going to write negative 10a plus 6a minus 5. Now we're going to split into two groups. 12 and 10 can both be divided by 2, and they both have an a. When I divide by 2a, I'm going to get 6a minus 5. 6a minus 5, the second two terms, don't have anything in common, so all I can factor out is 1. But that's okay, because 6a minus 5 is the common binomial. So I factor that out. I'm going to have 6a minus 5 times 2a plus 1. Check out the next page. Example 3, we want to factor completely. Some of these problems might have greatest common factors. If it does, I want to make sure I take care of that first. Let's be on the watch for that. Letter A does not have a greatest common factor, so I'm going to start by multiplying the coefficient of x squared and the constant. It's going to give me negative 240. Now I want things that go into negative 240 that add to 1. I know I want one positive and one negative because 240 is negative. And I know I want the larger number to be positive since x is positive. So let's start with 24 and 10. So 24 minus 10 is 14. Not quite there yet. Let's keep going. You might need to grab a calculator to help you. If you divide 240 by 12, you get 20. So 20 minus 12 is 8. Again, that one doesn't work. 240 divided by 16 is 15. So 16 minus 15 is 1. That pair is going to work. So let's get this set up to factor by grouping. I start with 10x squared plus 16x minus 15 minus 24. Now we group the first two terms and the last two terms. 10x squared and 16x have 2x in common. I can factor that out. We're going to be left with 5x plus 8. And I can divide both 15x and 24 by negative 3. So that's going to leave us with 5x plus 8. Now, since 5x plus 8 is the same in both groups, we can factor out the 5x plus 8, and we're left with the second parenthesis as 2x minus 3. Let's look at part B. Nothing in common between all three terms, so we're going to factor this one by grouping. If you multiply 3 times 10, we get 30. We're going to want two positives to get that positive 17. 30 is 3 times 10, and 3 plus 10 is 13, so that doesn't work. 30 is also 15 times 2, and 15 plus 2 is 17. That's going to be the right pair to get the 17 in the middle, so let's set this up to factor by grouping. This is 3x squared plus 15x plus 2x plus 10, and we're going to group. The first two can both be divided by 3 and x. If I pull that out, you're left with x plus 5. The second two can both be divided by 2. If you pull that out, you're left with x plus 5. X plus 5 in common. Factor the x plus 5 out. We're going to have x plus 5 times 3x plus 2. In part C, I have, again, nothing in common, but I can use the first and the last to get this factored. So 32 times 3 is 96. If I break down my 96, I know I'm going to want two negatives to multiply to a positive and add to a negative. I want to add to a negative 28. I know that 96 is 32 times 3, so if we try negative 32 and negative 3, that adds to negative 35, so that one doesn't work. We also can break down 96 into 24 times 4. So negative 24 minus 4 gives us negative 28. That pair does work. So let's set this up to group. 32x squared minus 24xy minus 4xy plus 3y squared. Group the first two and the last two. 32 and 24 can both be divided by 8, and they share an x. So that'll leave us with 4x minus 3y. In the second group, the first term's negative, so factor out a negative, and they only share a y. So when you divide the negative and the y out, I'm left with positive 4x. Positive divided by negative is negative 3. One of the y's is gone, so there's still one left. 4x minus 3y is in common, so we're going to get 4x minus 3y times 8x minus y. Let's look at part D. Multiply first and last. 9 times 4 is 36. We're going to need two positives here to multiply to a positive and add to a positive. 36 is 9 times 4. 9 plus 4 is 13. So that doesn't work. Or how about 6 plus 6 is 12? That's going to give us the 12 in the middle there. So 9p squared plus 6pq plus 6pq plus 4q squared. Factor by grouping here. 9 and 6 are both divisible by 3 and each has a p. Pull that out, you're left with 3p plus 2q. 6 and 4 can both be divided by 2 and they both have a q. Pull that out, you're left with 3p plus 2q. And since 3p plus 2q is in common, you're left with 3p plus 2q times 3p plus 2q. Or, since those are both the same, this is 3p plus 2q squared. Let's look at the last two. 12, 28, and 8 can all be divided by 4, and they all have a k in common. Let's divide out the 4k first. That's the greatest common factor. It's going to leave you with 3k squared minus 7k plus 2. Let's keep going to see if we can factor this further. 3 times 2 is 6. That's positive, so I know I need to have two positives or two negatives. And since the 7 is negative, it needs to be two negatives. 6 is 2 times 3, so negative 2 minus 3 is negative 5. Doesn't work here. Or 6 times negative 1. That one does add to negative 7, so we're going to use that pair. Keep the 4k, and we're going to factor the rest. So we're going to have 4k times 3k squared. Replace the 7k with minus 6k minus 1k plus 2. And we're going to factor by grouping. 3 is in common in the first two, and so is k. Divide that out, you're left with k minus 2. The first term is negative, so divide out a negative. Only a 1 is in common. So if you divide out the negative, you're going to get a positive k and a negative 2. So k minus 2 is the factor that's in common there, times 3k minus 1, and don't forget to bring down the 4k we factored out at the beginning. In part F, 20, 38, and 12 can all be divided by 2. Let's factor out a 2. They all have an x and a y in common. So if I divide out 2xy, we're going to be left with 10x squared minus 19x plus 6. Okay, let's see if we can factor this further. 10 times 6 is 60. Since that's positive, you're going to need two negatives to get the negative 19 there. So what goes into 60? We know that 6 and 10 would add to negative 16, so that won't work. We could try 20 times 3 is 60. That would add to negative 23. That's not going to work. But 15 times 4, 15 and 4 will add to the negative 19. So we're going to use negative 15 and negative 4. Let's get this grouping started. So 10x squared minus 15x minus 4x plus 6. The first two have 5 and x in common. Factor that, you're left with 2x minus 3. Start the negative, and they have 2 in common. Left with x minus 3. If you factor that out, you're left with 2x minus 3. And so my final answer is going to start with the 2xy that we took out from the beginning. Then it's going to have the 2x minus 3 that they have in common. And finally the 5x minus 2. That's fully factored.